And we're live. Okay. Hello all, hello world. Hopefully everyone's doing all right. This is day 94 of studying compilers every day until I land a compiler role. Yeah. So last time we worked on a bunch of debugging stuff, and it was a pretty good initial push. But we hit a point where I could no longer figure out what's going on, and my solution was turning rather messy to address those issues. And the one thing I've learned just from like working on this project is that like if your solution is becoming really messy, that's probably a sign that your data structures need to change. And I thought about that and I was like, yes, we probably need to make some changes here. I think the biggest issue right now is that I'm using shared pointers, which just doesn't make sense for the task at hand. Therefore, I think my plan is gonna be to avoid using unique pointers and do my best to, I guess, switch back to avoid using shared pointers and go back to using unique pointers. What's good, GIW? Good to see you. Yeah, so that's gonna be our big goal for today, just a big rewrite. How's the backend going? I got it to, so I'm still in instruction selection. It's been a hot second. I see, okay. That's YouTube tag moment. Yeah, so I'm still in instruction selection. I've been trying to figure out how to get tree merging to work properly. I've debugged all of like initial tree generation, which is good, but I need to clean up my tree merging, and there's a lot of stuff that needs to be done for that to, I guess, be reasonable. Yeah, so I guess that's kind of everything I'm going to do today. While I'm at it, I may as well update. I guess I should start with updating our data structures here. Yeah, so there's a lot of shared pointers. Yeah, let's just replace all shared with unique as a start. You can close out that for a second. I think this is fine. Backend's definitely the thing I know the least about. Yeah, that's fair. It's kind of just like, it's kind of a black box to a lot of people, I think. And like everyone cares about like, I guess, other parts of the compiler. Like all the like compiler proper people care about the middle end. All the PL people care about the front end, and like I guess the back end is, I think, generally just seen more as glue rather than like something that's interesting to study. Not that that glue isn't interesting. As a matter of fact, I think it's very interesting, but yeah, I think people just like don't really get it, which is fair enough. Okay, so let's see. So you have a unique pointer of node. Should this be a unique pointer actually? Yes, this should be a unique pointer because we're keeping a list of them here. But then everything else I don't think should be a unique pointer. So this should be node star. Yes, because this is a skip list. So the leaves all live inside the tree. Yeah, inside this node that's in the unique pointer. It's a pointer to a child of it, I guess. And originally my plan was to like literally replace the node, but then I thought about it and like there's not really a good way to do that regardless. So we're gonna stick to the whole identity theft thing, and that will be pretty funny. Okay, so we have that. Pop should be unique pointer still. Get leaves should be node star. Yes, that's good. This should be node star. That should just be like, that should be a mapping. Okay, I think that's all the changes we need to make here. We just need to, I guess, make all the updates here now. So let's do the same find and replace. That should solve a lot of things to begin with. Yeah, because we're moving things, so that's fine. This should be node star. Yeah, that makes sense. That makes sense. Oh, right. I need to change in here. Should we node star as well? Okay. This is that. This should be. What type is this? This is unique putter type. It shouldn't be a unique putter type. There you go. That should be fine. Unless I'm like tripping. Oh wait, I need to update toString visitor. That's here, yeah. Right? Figure out how a function competes with CRC and using an x86 instruction. Yeah, it's like a lot of crazy stuff. There's like, it's all stuff that honestly is beyond me, I fear, but it's quite cool. What do you think of Temple OS? It is the best OS ever made. We are lucky to be able to use it even, I would say. What type is this? This trees. This is list of wait, what? Oh, wait, yeah. Oh, this needs to be a ref. Whoops. Okay, that makes sense now. Okay. I think that's all the rewrite there, at least. So now I need to update gen trees again. Yeah, there's so much to change. Oh boy. Okay, let's get started with this. This is a shared. So I guess this should be make unique. Yeah. This should also be make unique. Are you making your own compiler? Yes. My compiler is going to go from C to x86-64, or at least a subset of C. I'm gradually bringing everything up, but it's gonna be a while, I fear. Yeah, let's just look up shared. I think that will make things easier here. Should be unique pointer. Okay, nothing else there. Unique pointers, okay. Yeah, not a lot of this has to change beyond just like literally just like, I guess, man, English elides me today. Not a lot of this needs to change, barring just like changing a lot of like the word unique to, or a lot of the word shared to a lot of the word unique. This will be an interesting case I need to figure out. Yeah, this will be something. Oh wait, no, I'm stupid. This should be get. Yeah. And then that should solve everything. This should be unique. What is op? This is a shared putter. This should not be a shared putter. It's unique putter. Okay. Yeah, that kind of cleaned itself up really quickly, huh? Yeah, okay. So we can do that. So we store the internal pointers inside here. Yeah. So that all works, I think. I would hope. Are you planning to make this public when you finish? It's already public. The repo is on my GitHub. Feel free to take a look. The quality of the code it generates might not be as impressive as anyone wants it to be, but from a pedagogical perspective, it might be worth a look at least. But if you're looking for like the next fast next best technology, this might not be it, I fear. Not to say it won't become that. That's how a lot of the mainstream open source projects came to be, but at least the primary goal of this is for me to just learn about compiler design. What is happening? Oh, another instance. Okay. This seems not ideal. We should be adding the leaf, I think. It's another unique footer. So we should store literals in the leaves, I think, still. That would at least be the correct thing to do. Yeah. Who knows, we might do like some sort of strange coalescing in the future. Okay. Yeah, like I keep this anyway. It feels wrong to not insert that at least. That. Okay, these need to be unique. Have you considered switching to Linux? My primary laptop that I like take to class and stuff is running Arch. So in that sense, like I do use Linux. This machine is specifically Windows because I have a Valorant addiction, and that needs to be resolved in some capacity. And the only way I can resolve it is, well, through Windows. I've thought about dual booting. I've just been kind of lazy about it, so that's kind of the only reason I haven't been running Linux on this explicitly. Like, it is what it is. Yeah, unfortunately Valorant is a very real consideration I'd have to account for. Okay, it doesn't look like a lot else needs to change here actually. Most of the stuff is good to go already. Yeah, that just needs to make unique. This needs a unique. This needs a unique. Okay, is anything shared? Nothing is shared. Perfect. And nothing is yelling at me, so I think I've done everything correctly for this. Yeah, okay. So add source. Bye unique. Or shared putters. Hello unique putters. Okay. So now we actually need to clean up merge trees, which does not bring me joy in much of a capacity. We still have shared putter here. So unique putter list and node is the result. This should be unique putter. Have you come across any security related concerns or topics yet? There's like not too much that I've been looking into at least. Oh wow, I can't spell. 1 second. Unique. Okay. But yeah, it definitely exists. I know there's like a lot of like obfuscation stuff that exists, and it's like interesting to think about, and also like de-obfuscation. I haven't looked into it too much because I'm still kind of at level 1, I feel like. And also, like, I care more about optimizations rather than obfuscation generally. But that's just me, so. Yeah, that's kind of just my take at least. Where else do we have shared? That's where we have shared. Okay, well that actually fixes a lot of the errors somehow. We're gonna need to clean up a lot of this code though. I really hope it sucks less. It might just be doomed. Yeah. Okay. So how do we even go about cleaning this up? This doesn't seem fun. I mean, I guess we could just like, we could like fix all the small things first. Or at least just like, what am I calling get on here? Let me just start this. So that's a node star? Yeah, okay. I guess we can just like get rid of all of these for now, and then we can go from there. Yeah, okay. Let's see if this even builds. This was not a DM. Lol. Okay. So this is all built. Let's see if this breaks anything. Oh. Okay, I guess. All right, I guess WSL is doing WSL things. We might have to give it a second. Yeah. Okay, there it is. Is there a rationale for using a std list everywhere instead of vector? Yes, actually. The big problem is for a lot of places I need to be doing a lot of like insertions and deletions at like arbitrary points for like analyses. So like if I were to like move instructions around or like insert or like delete a new instruction and insert an instruction at some point because I'm like transforming the memory representation of the code. If I were to do that with vector, each of those operations would be O of n, whereas they're constant time. Or at least like a better time complexity. I don't remember off the top of my head if it's constant time. But the time complexity is a lot better with a list at least. I imagine like, yeah, I'm not sure actually because you'd have to like traverse it, right? Let me look this up. Insert, delete, time complexity. Yeah, okay, so usually like I'd have an iterator to it, so it'd be constant time. But if I need to search, then it'd still be linear. So at worst, it's equal time complexity, but in the average case, it will be better. And it just scales better with that. Usually when I'm like iterating, I'm gonna be nuking the cache anyway. So it's not like the contiguousness. The memory packing. Yeah, the memory packing of the vector matters a lot less, at least in this instance. Since we're working with like more DAG structures, I guess. Or I guess no, just digraphs. They have cycles. So there's directed graphs. Okay. So we built it. Is there like a run command I can do? No. Okay, let's run build and, or let's actually run debug. So we want test, regression, input, test. Okay, so it's segfaults. That's not ideal. What IMs are these? That's a good question. I don't remember. Oh, they're the 02s. I think it was like, yeah, it's the ones that like Critical worked on. Okay, so we're segfaulting a lot. Let's just run mentreg on this. Yeah, that's not ideal. So what does it look like with just that? Huh. Okay, so I guess that actually works perfectly. How are they? I think they're alright. Like, for their price, I think it's pretty solid value at least. I'm not really too much of an audiophile. So like the previous, I've had like 2 sets of items before. I forgot what one of them was. But my point of comparison is like the Moondrop True 2s. I think these like fit my ears the best at least, which is kind of the biggest thing that's annoying me about previous items that I've had, and it's just been like, I guess, pretty solidly durable. I can't really complain, especially at their price point. I imagine if I were more audio, if I had like more mature ears for like, I guess, hearing minute differences in different different audio settings, I think I would have a more informed opinion, but I think they're pretty solid at least. For like the average person, I think they will do more than just the trick. Okay, so let's rewrite this entire thing. Yeah, this was not ideal. I think what I will do is I'm going to what are we merging? How are we merging? What are we merging? I guess I could just walk through this again. So we have the context. We're just stepping through each node. Just a note for itself. It's reverse because the list is, we assemble the list in reverse here because we're pushing front. Yeah, so this makes, oh boy, where am I? Okay, so we get this stuff. If it's not a register, we can't merge it, so that's fair. We get the leaves. We iterate through the leaves. We use an iterator here because we need to copy it later. So this is fine. Oh yeah, that's another advantage of using a list. When you delete from a list, it doesn't invalidate iterators, which is really interesting. As long as it's not like, as long as the iterator isn't at like the thing you're deleting, the iterator still maintains validity. Which is another like interesting consideration. It's not something that I'm like caring about as much, but it's like still really cool at least. Let's put this line up here actually. I think this will, yeah, let's put it here, I guess. Okay, so we get 22 reg. As you're studying, do you write notes? I don't know, historically, I don't think notes have been too helpful for me in terms of like formally studying something. I think the main value I get is just out of like projects, because then I get like literal hands-on experience and I can kind of like, I guess I've like manually debugged all of the like design issues, so like I have a more solid idea of what's happening. It's um, like if you were to learn about like Dexter's algorithm, for instance, like if I don't know if you've like taken a computer science course, I'm not sure what your background is, but like if you were like going through an algorithms class and like you learned about Dexter's algorithm, which is like everyone's favorite like first year difficult algorithm, you could either like understand theoretically what's happening by like stepping through it, or you could just like write an implementation and then you will understand through, I guess, like A, coding out the implementation, and B, debugging it to, I guess, like that will be probably just as good if not better for developing an understanding of what's happening. So in my case, I lean more towards like project-based learning. So my form of studying is like literally just building the thing, I guess. There's some things that like don't make sense for that because I care a lot less about them. Like if I were to learn about databases, I would probably just stay in theoretical land because for the most part, like barring just like enough knowledge to like use a database efficiently, I don't think I would like, I'm like relatively uninterested in, I guess, like actually making the database. But for something like compilers, which I literally want to like work on for a living, I think it would be important for me to have that deeper understanding of internals. So I guess like I don't necessarily write notes, but I guess my notes are the project work in front of me, if that makes sense. I can actually pull up a file that is a solid example of this. Let's see, the middle end. So there's this one, I guess like, there's this one step in a lot of compilers, which is like, it's called SSA construction. It's like transforming the, I guess the memory representation of the code into like, I guess a different form. That's kind of like the practical importance of it. So what I did was I read all the theory about it, and then I like literally just like re-implemented it by hand here. So there's like a couple steps here. Most algorithms break it down into like this step called fee insertion and then this step called variable renaming. So I implemented both of those, combined them into one big pass. Here's like the logic for each, like, I guess, instance here. This is like a little algorithmic helper I have here. Oh wow, that's messy. Yeah, I need to clean that up eventually. But yeah, this is like an example of something that I guess counts as quote-unquote notes. Clang uses SRA. Does it actually? Oh, interesting. Transform breaks up allocates of aggregate type. Oh, interesting. That's really cool. I guess that makes a lot of sense. Oh lord, there's a lot of... full blind. My fault, 1 second. Yeah, that makes a lot of sense. What is happening here? Yeah, I think traditionally at least, most compilers still just use like mem2reg. What is happening here? Yeah, that's really interesting. I think if I run -o's, I guess we could check what passes it runs. Let's see. Okay, yeah, we can just do that. So we have an IR viewer. How do I like... Let's see. That's not helpful. I see. I think remarks might be the place. Right? Is this? That's not helpful. Okay, so it's not remarks. Pipeline? Yeah, there we go. So can we look mem? Sorry. Okay, so it's running neither? This is 1 dash, right? Yeah. Okay, well that's not really helpful. Oh, wait, I see, wait. Yeah, SROA. Interesting. Wow, okay, it actually just doesn't use memtarget anymore. That's really cool. I guess that makes a lot of sense. If it does, like, if it does the job, it does the job. And also, like, memtarget is, like, low-key difficult, so it's low-key a mess. But yeah, I guess, like, that seems reasonable enough. Well, the more you know, I guess. That's really cool. I should probably look into this pipeline a little bit more thoroughly. What happens on Dasho 3? Also SROA. Yeah, okay. Yeah, okay. Fair enough. That's really cool. Came across an effort by a professor who wants to make a new programming language that merges deep learning and symbolic AI concepts. Yeah, I think that's pretty cool. I think my main focus when it comes to compilers is like in terms of like the optimizations we can make, and less on like the programming languages side. So I think like my interest in that sets a cap on my interest in it, but it still does seem rather cool, at least. Okay, so yeah, this naming will have to be verbose, I fear. I think this is a fine pass, or like a fine instance here. This is fine. I think this is fine, actually. This looks fine. I might have to check that later, but that's not where all my issues are coming. The issues are coming down here, at least. Okay, what is happening here? T2 scene. What was I doing with that again? Wait, what? Oh, I see. Or it's like... Yeah, so this was like the register we're matching. Have you watched Jonathan Blow's compiler streams? I have not. The name is familiar though. I remember, I think in game dev today actually, his name was mentioned. But no, I haven't watched very closely. Let me look him up actually. Oh, this seems like a nice resource actually. He seems like a vibe. Yeah, I might give him a watch. Yeah, we were talking about like spherical lerp today in class, so I guess it makes sense that he would come up. Just for like game dev related reasons. That's all really cool. Yeah, I think the more I learn just in general as like a programmer, I'm starting to realize like kind of everything is programming languages in disguise, and it's really funny to think about. Kind of angry all the time, but his language is kind of cool. Fair enough, yeah. I mean, like, if I don't blame him for that. I think like the more tenured someone is in the in the CS community, the more permanently upset they are. I want to make this less. I want to make these less verbose. I hate the way these are. Where does this live? This is in here. Let's just shorten the name. Yeah, that's better. Or I guess, yeah, it should be set meminst. Yeah, this was annoying me a lot. There we go. So now that straightens out a little bit as well. And this also is a little bit less ugly. The language is on build system? Interesting. Build systems are scary to me. They're like so archaic to me. There's like a lot of stuff that happens behind the scenes. There's a lot of people to cater to. A lot of respect towards people that work on them. Okay. So what do we want to do here? So we can make real quick. We could see how this is doing. What's wrong here? Set mem inst. This is, yeah, this is set mem inst. Right? Okay, yeah. Let's try building again. It's looking good. Seems fine so far, that's a good sign. Okay, well that's still sec false, I guess. That's fair enough. Actually, if I just do this without opt. Wait. Why doesn't that just merge? Inst underscore combine. Am I done? Why can't this merge properly? This should be foldable. I don't know, whatever. That's a future issue to worry about. Yeah. Interesting. That should be folding. I'm not really sure why it's not, but oh well. I'll have to figure that out some other time. Inst combine. All of my passes are kind of just like a spaghetti code pile of mess that needs to be sorted through. Yeah, it's all maintenance at the end of the day. Okay, so how do we merge? I think we should move the consume. Actually, no, the consume there is fine. We might want to rename it from consume to something more descriptive, but consume is kind of a good start. Okay, so we want to find here. I'm gonna get T2 iter. Right? Wait, no. Yeah, wait, no, yes. We get rid of T2 iter. And then we want to push back the cur reg's leaves. Wait, should this be cur? Cur makes sense. I think there's some funky casting stuff happening here. That might be what's happening. First time catching stream live? Welcome. Good to see you. Found any solutions since yesterday? Not quite. I think it's kind of just more of the same stuff that I was thinking about, at least in terms of like, just like doing the big rewrite, and then like cleaning up whatever is left and praying that whatever is left is like easier to read. And it's already looking a little bit better. This variable is way too long. I really need to shorten that somehow. Yeah, so this should be an or, I think. That logic was just wrong, but I don't think that's what was causing our issues earlier. I still think it's somewhere in this loop. I'm fairly sure it is. Why is cur different from cur iter actually? Cur and cur iter should be the same thing, right? What's wrong with long variable names? They just take up a lot of space, and I guess the word here is clutter. So like you'd need to like, it's not like a balancing act. And I've historically been a fan of like not abbreviating things. It's like cur leaf uses as opposed to just like leaf uses, or like cur leaf reg instead of just like leaf reg, for instance. But at some point, I think some of them are just like way too verbose, and horizontal space is like a genuine consideration. And when you're when you have like too much stuff in one line, you have to like split up into two lines like this, and it just like it all becomes a mess. So even if it's like more descriptive, I think like it's not like a very case by case basis, at least. Yeah, that's kind of my take on it, at least. As always, the answer is it depends non-answer. Oh, wait, what? What am I doing here? Wait. Okay. That might be the cause of a lot of issues we had. So you have that. Curleaf uses that curleaf reg. Wait, no. Oh wait, no, this is fine. So we get the name. That makes sense. So then we can find for cur. And cur iter only exists like in there, so we can just make this cur, to be honest. Oh wait, no, this needs to be deref. LVM variable naming is the opposite? Yeah, exactly. That's kind of that's like what I want to avoid, because like in another project I've been working on, which I can't show because it's supposed to be like closed source, but like and so like it's like a simulator for like the game Battle Nations, if you've played that back in like 2010. It like came back like last year, but I've been playing that a lot. I've been working with a couple people on like a combat simulator for the game. So like the way we like, so the game has like 2 boards of units, and then each unit has like some number of weapons, and each weapon has like some number of attacks that it can use. So like the way we like index it is like, the way we access is through like a getter that takes like row, column, and then like weapon index, and then like attack index. But then like it gets really awkward because like the function parameters take like weapon and like attack as like the indices, which was a poor design decision on my end, but that's a different story. So then like when I'm actually iterating through, I need to use like W and A, and then like it becomes messy because then like in some places W is the index, in other places weapon is the index, and it's just like it's a mess. I want to avoid that as much as possible, while still making my code at least like readable to someone that hasn't seen it before. So that's why I err towards like longer names in general. As long as like it preserves information, I think that's, as long as it like carries some degree of meaningful information, I think it's fine. Okay. I think that might have been the bug. Cur instead of cur leaf. That's a little bit insane. So let's try this again. If this works, I will be very surprised. Okay, well it's segfaults, so it definitely doesn't work. It sure as hell does not work. That's a lot less ideal, I think. Okay, let's give it a different test, maybe. Not inst combat, or pop, I think, is the simple one. Yeah, that one. I guess there was nothing really to combine there, huh? But it looks like it handles that case at least. Let's try this one. Let's step through this more, I guess. Let me just like look through this one more time, because I swear something is wrong here. Yeah, we just, so cur leaf uses, so we get name of the cur leaf reg, and then we want to replace cur. Oh wait, cur doesn't have children anymore. Wait, yeah, because we did consume already, I think. Or no, the children still exist on cur actually. It's just like the literal. The node star should stay the same because the pointers have a layer of indirection from the unique pointer, so I'm not concerned about that. Curly fridge and continue. Or if it's not a register, then we skip it. So then it's a register. Let's rename that, I guess, as well while we're at it. Yeah, that's fair. I think most of this is fine. Clearing uses is fine as well, because we're going between. No, we shouldn't. We shouldn't clear this here, I think. Don't think you can deref std find. That's what I thought, and then I looked it up. Find returns an iterator, so you can deref it. As long as the iterator is mutable. You can just deref it and then replace the value in it. I thought that was really cool, at least. Maybe this is causing issues, actually. Why am I clearing uses? No, I need to keep uses. What happens if I comment that out? Oh, what's good sucks. I haven't seen you around. Okay, let's do that stuff. Okay, well it's segfault still. That's not very ideal, is it? Let's see. What else needs to change here? So let's try to merge here. I could probably print the name, actually. Yeah, I could definitely print the name here. Let's do t2 reg get name. Yeah. Arrow. Whoops. Okay. That should be good. Merging 2. Why is it merging that one and not 3? Oh, that's an iteration order thing, huh? It should be trying to merge 3 first, not 2. That's not ideal. That's not very ideal. I think. Right? No, it should be safe. What were we trying to merge into what? We're trying to merge T2 into T1, so this is fine. Yeah, that should be a safe attempt at a merge at least. So why is that causing issues? I guess we could try to print uses. Let's do str and then list in uses. Yeah, let's print this. Let's do that. Or whoops. Do that, and then for in uses, let's go ref real quick. And then these should be like, what are we inserting into this anyway? It's just all the leaves, right? Or uses at get name. Oh, I see. Okay, so then this should just be like any generic node type, I think. Let's just be lazy with this. We have a two-string visitor here. Let's give it LM. Do that. Let's do alright, let's move this to a new line. TSM? TSV, whoops. TSM. I'm not sponsored. Please sponsor me. Okay, so we want TSV, get result. We'll just be lazy with this, so we'll just like end like that and then like stood, cout, end line like that. And that's just like one row. We can do that very lazily. And this will print at the start of the cycle, I think, right? Yeah, okay. Which terminal are you using? This is Westterm. So 0 used by 2. 1 is used by 3. 3 is used by 4, and then 2 is used by 4. Okay. Okay, so we should probably just print out each cycle then. I think that'll be the easiest way to figure out what is going wrong. Okay. Wait, it's breaking in the merge? That's where it's breaking? We're not even getting to this point yet. Alright, let's run it through Valgrind. I'm quite confused why that's what's breaking of all things. Okay. Oh, that's a lot longer than it was last time. So merge trees at 60. This is here. What the hell? What are we trying to deref? Oh, wait, I'm printing in the wrong place. That makes sense. So we should print it in here. There we go. All right, let's print again. Let's see what happens after. If it breaks on the print, then we know exactly what's going wrong. Okay, well, I think it might be breaking on the print. I don't know about you guys, but I think it's breaking on the print now. So let's see what it's doing, why it's breaking on the print. $153. Wait, what? Oh, so that's where that's called. It's breaking at 60. It's still breaking at 60. Why is it still breaking at 60? Oh, we need to break. Yeah, we need to break because we found the thing. Let's try again. Alright, something else is breaking now. Oh, okay. Now we're breaking in the print. I think. Breaking at line 38. Yeah, okay. So something's a null pointer. Something might be a null pointer here. Yeah, I wonder what's the null pointer. We should probably delete from the list then as well. Yeah, okay, that makes a lot of sense. Yeah, so we have uses here. Per leaf reg get name. Yeah, so this is the child node, I think. We can leave things residually in the forest. So I'm not worried about updating there, at least, I think. This one we're erasing. I guess I should probably like clean up this train car coupling mess. So here is where we start merging, so consume is fine. There should be auto something, and let's paste that real quick. Yeah, that should help with the readability crisis. Good luck, see you tomorrow. I appreciate the support. Thanks for showing up to the stream, and yeah, have a good one. So this should be old leaf. This should be new leaf. Yeah, that makes more sense to me, I think. Your project deals a lot with implementing types. If you're asking about the Rust project, there's like a lot of type nonsense happening, yeah, behind the scenes. Or I guess not really types. It's more just like structs, I guess. I would hesitate to call them types, at least. So here, placing the leaf, we're updating mem instruction. So now we're updating cur. Oh, we should update this last, it just occurred to me. Because all of that stuff relies on state from here, I think. Yeah, so this should go here instead. Yeah, so this makes sense. Yeah, okay. So this is like the bounds of the loop, it looks like. Yeah, so we can do that. Oh, wait, this might loop infinitely, wait. Right? Wait, no, this should be in range. Wait, what the fuck? No, yes, this should be in the range. So this shouldn't cause a problem. This shan't cause a problem. Okay, so also we shouldn't be clearing uses, I think. Because we need downstream knowledge, I think. We need to preserve that, at least. Yeah, so let's comment that. Yeah, we've commented that out. So what am I doing here again? What's good, Niraj? Good to see you. Still debugging, but I think I've made forward progress at least, so that's a good sign. Let's put the erase at the back of this, actually. Let's finish setting up NeoVim with Arch on WSL2. Good stuff. I feel like Arch is a little bit clunky on WSL, just because, like, I feel like the spirit of WSL is just that it just works. So I've been sitting on Fedora, but I think that's also fair. Stuck on putting a user in the servers file? Yeah, fair enough. I think, like, do you have to like chroot or like change into root, I guess, to do that? So what is happening here? This is new. Some old games were better on Linux and Windows 11? Yeah, that makes plenty of sense. I'm not even in the slightest surprised by that. I could combine these loops, by the way, but I want to separate logic for now. At least until like this is more well defined. Yeah, let's keep these curly for now. Yeah, Windows 11 is. I'm not happy with the direction Windows is moving, at least. This whole agentic desktop thing really confuses me, I will say. I don't really know what else to say about it, but it really confuses me. Okay, so we're replacing the use of cur with T1, which makes sense because that's the big tree. And then in what are we erasing? Oh, we're erasing the literal instruction from context. So this should go after everything, right? Yeah, that should go everything. So we're getting rid of the thing that we like. The thing that we stole. Remove her from context. Let's just rename this. Steal cur's info. Info from cur to T2. And then here we info, or this should be info in forest. Yeah. So this should be transfer. Or I guess like uses from cur to T1. Yeah, so that's what we want to do here. And then we should delete cur, I think. Or we should delete cur in this, I think, because no, we should delete T2. Yeah, we should delete T2 here, I think. Or does it matter? I don't think it matters. We can kind of just leave it residually. We're just updating everything that already exists, so I don't think we need to like do an explicit delete here. Removing from context, we definitely need to. So uses of cur used to be T2. Or uses of cur used to be to cur. Now they are to T1. Which makes sense. All of the info that pointed to cur should now point to T2, I think. Right? Or wait. Cur to T1, I think, right? Yeah. So T1, we want to get rid of what T2 was in the leaves, and we want to replace it with the leaves of cur, which makes sense. And then here we update the mem instruction-ness of T1. OpenAI Linux is a refugee camp for old laptops. The crazy thing is, like, even newer laptops just run better on Linux, I think, which is really funny to think about. Like, Windows just chugs through battery life, it turns out. So if OpenAI next comes out with a ChatGPT OS, surely they don't do that. I doubt they will. Perplexity already exists. It's not even like the spyware that I'm concerned about. It just sucks. I genuinely just think it sucks. Yeah, I think they will drop off the planet before all that happens. Alright, let's see if this works. Oh, crap, it doesn't work. Okay. Do I have water? I hope I have water. Okay, I have some water. Stay hydrated. Also, posture check while I'm at it. Good to stay hydrated. Are you invalidating iterator? I shouldn't be, at least. Or at least the iterator should still be fine, because unless I'm erasing the current one, actually, there's a chance that that's happening. But I don't, it's getting to the next one, so I don't think it's the iterator's problem. It's failing when we're trying to print, oh. Wait, is it the print instruction that's breaking? Wait. Because if it's the print, then we need to erase. Which would be a really funny outcome. Where's the print function again? There's the fuck-ass print instruction. Because we're printing to something that's been null pointered. Or we're trying to print out something that's null pointered. If this works, then that'll be the funniest thing ever. Okay, well, it doesn't quite work. It's still segfaults, but it segfaults differently now. Let's see why it segfaults. Let's see, more vomit. Okay, predefined ops. Algo base. What is algo base? Algo. Merge trees 127. Okay. Oh, interesting. Huh. Why is this find failing? This shouldn't be failing. Where in optimization do you start implementing combinatorial optimization? I think the term that is generally used for this is canonicalization. So like, if you have like number plus variable and like variable plus number, you want to decide on like if I'm understanding you correctly, the issue you're mentioning is like too many cases to account for, causing like maintenance debt, all that, the whole usual pile. So like the solution, I guess like the optimization you're talking about is usually described as like a canonicalization pass. I think LLVM has, it doesn't like actually explain what the canonical form is anywhere, but there are like, I guess like standard forms, I guess, that everything can reduce to, I guess. Yeah, so like stuff like this, for instance. Or like ordering as well. I think there's like a reassociate pass. Yeah. Yeah, this is another example of something that would help address that. Yeah. If you asked me any of this like half a year ago, I would not have been able to answer this, by the way. This is all like, I think I would never have learned about this if I hadn't started streaming, which is really funny actually, because that means like I would have been significantly less employable. But yeah, let me know if you have any more questions. I'd be happy to answer whatever I can. Okay, so what is breaking in here specifically? So we know it's in the iterator. Invalid read. Wait, what? $127. So is this find? So we do have to erase actually. Okay, yeah. So if we're doing like these find-based algorithms, then we do have to erase dead values at least. Low level when you're going from segfault to segfault? Yeah. Okay, I think I know what's happening. Remember like 5 minutes ago when I said that like it's probably fine to leave dead values because we're never reading them? It turns out if we're iterating over them, we are in fact reading over them, which is a very big problem here. So, yeah, let's get rid of the dead values. There should be a way to do this. Yeah, so we want... This is fine, I think. So uses at curly. I don't think this one matters. I think the one that does matter is inside leaves. So this is where the segfault is happening. Oh wait, no. That is literally... Yeah, okay. Wait. That's confusing. So what are we erasing? We've erased the old leaf. What is old leaf? This is... Alright, this is T2. Okay, so any reference to cur we need to erase. Okay, we should uncomment this actually, because this is still important, I think. Use it, or... Yeah, we should erase. Does old leaf ever fail? It shouldn't fail, because everything up to, or like to get to this part of the program, it would have to succeed. Where am I? Yeah, so cur is like, I guess let me just like draw this out. Yeah, so the way our tree is structured, so like let's say we have like an op here. So we have like C, this equals like plus, and then we take like reg A here, and then we have like reg B, for instance. And then we have like somewhere else we have like reg B is defined as like, we add like 1 and then add 2, for instance. So what we have here is, there are 3 nodes we're looking at. The first 2 are the 2 nodes that we're trying to merge, which makes sense from like a pretty intuitive standpoint, because like we need the 2 nodes we want to merge into each other to like do the merge. The third one we care about, which I'm going to circle in green, is, I guess, the local copy of the node that we're trying to replace. So this B is going to take the spot of this B here. And what, I guess like the variable that represents each of these. So this C here is T1, I think. And then this B down here is T2. And then this B over here, this will be cur. So to get to the point where we're actually here, we probably should have all these defined. So the for loops guarantee that T1 and T2 exist. These are also just like kind of invariants that we enforce. And then cur should exist because we check if it's a register, and then we do a comparison between T2 and cur, and they have to be the same register. Yeah. And that implies that cur needs to be non-null. So at this point, it should exist. And this consume, it doesn't actually like delete the register. It just like takes all of its dependencies and just moves them onto T2. So like, what we're doing is we're literally just like, this is what I mean by identity theft. We're taking like this blob here. Is this color readable? None of these colors are really readable. This will do. So we're taking like this chunk here, and we're literally just transplanting it onto the bottom of the B here. So we're literally making like a plus and then like 1 and then 2 here. Or at least we're like literally moving this over onto there. So that's what the consume does at least. And then everything else is like updating dependencies. But this doesn't actually kill this B node object. It just steals all the stuff inside of it. I made a grave mistake called grabbing the wrong hot sauce. Yeah, that one's a little tragic. Hopefully you survive to tell the tale from that one. Some sort of AST construction or copy. I guess it's not really either, I guess. It's more like a move, I guess. There really is no better term to describe it. It's like... yeah, it is just like moving all of the children over. So in a sense, it's like construction. I think you like kind of are... You're like kind of on the... I think like you kind of get what's happening. Stealing the children? Yes, exactly. Yeah, so we need to... I think I'm missing an erase somewhere in something we're iterating through. Yeah, so this find is what's side-faulting. So T1 leaves. We're missing an erase, right? Wait, how are we missing an erase? That doesn't make sense. Wait, what? Oh, wait. You fucking know what? We can't really... Yeah, as a vector, an erase doesn't really do what we want it to, right? That doesn't move everything forward, I think, right? Does that just like know the element? Yeah, okay, that doesn't do what we want it to, I think. Oh wait, no, it does do what we want it to. What? Yeah, so that shouldn't cause any issues here. Really shouldn't mix my tram skull with heat. Yeah, that's like... That is quite some Russian roulette there. What's good, John? Good to see you. It's been a hot second. I imagine you've been busy with life, so like, it is what it is. Don't worry about it. Got a job? Good stuff. I want to make a parser and lexer in Java. Where do I start? Honestly, just like literally anywhere. It's kind of... I think if you have like a language you want to like make a parser and lexer for, then like by all means just go for it. The fun part about a parser and a lexer is I don't think it really requires many external dependencies, if any. So if you want to make that by hand, just like find a book, any book. I think crafting interpreters might be useful for this. Yeah, if you know of the webbook Crafting Interpreters, that'd probably be the best resource to start. But yeah, you can kind of just go for it, I think. We ever use priority structures? It's hard to find much of an instance here, at least. There might be, but it's hard to say. I don't think I will for the most part, though. I just don't really have a use for it, at least, if that makes sense. If there is a use, then I'll probably stick to just like the C++ priority queue implementation and call it a day, though. However helps. It kind of does the work for you, to my knowledge. Yeah, so it's a parser generator, which allows you to like define your language as like a I guess like a grammar. So something like this, for instance. And then you can like give it arbitrary text, and then it can parse it using that grammar. Yeah, it like, cause like if you want to like write a parser by hand, you have to like do a bunch of like if-else-if chaining, and like that's really annoying. So so a parser generator helps by just avoiding that, I guess. And also it's like a why reinvent the wheel sort of deal, I guess. That's kind of my understanding of parser generators. This project here actually uses a parser generator for the AST, or the parser, I guess. Yeah, so this is like all of my grammar stuff. There's like all the main tokens. This like defines expressions. I'm gonna go through it quickly because it's all on my GitHub and you can like read through it more if you want. It's all very verbose. And then like here's all the instructions. And then that builds up to like a function and then like I guess an entry point, which is the minimum required parsing unit. Yeah, of course, let me know if you have any other questions that come up. So, I keep forgetting what is dying here. Yeah, so there's a null pointer somewhere in cur leaf uses? 127, so not uses. And leaves. What is T1 leaves? Oh, right, it's T1. The leaves of T1, I see. Yeah, that's a ref. So that is the leaves of T1. Yeah, so we move back all of those. None of these should get invalidated, or none of these should become null. Why is this still breaking? So you've only added things up to this point. And the erase shouldn't cause any issues, I'm fairly sure. Assert? I don't even know what I would assert though, I guess. So we're replacing all uses of T2, or no, we're replacing all uses of cur with T1, and then we're replacing all uses of T2 with cur. That's really confusing, actually. Wait, no, wait, I think that's it. Yeah, cur shouldn't exist anymore, I think. So if there's an instance that if we're like replacing something with cur, then that would be bad. Info, so this is leaves, so we should be getting rid of T2. That makes sense to me. It's replacing T2 with cur? Or wait, no. We're replacing T2 with the leaves of cur, so that's fine. I think it has to be here somewhere. So uses at this is cur, so this should be like new leaf, I think. Yeah, so this we're replacing cur. Yeah, that's a putter. So replacing cur with T1. Let's just like print. That should be fine. That does exactly what we want it to. Right? What? data structure is this again? Map from string to list of node star. So what are we finding by Ker's name? Oh, did we move the name already? Wait, there's actually a chance that's happened. That would be really funny if that was the outcome, because that would be completely unnecessary. There's no reason I would need to do that. Reg node, there we are. Okay, this is all it does. So we just move from other to cur. So that should be fine. Okay, so we did do the thing. We did the erase. Maybe I should just print. I should like just fix the print, I think. That might be what I need to do. Let's just erase from uses. Let's erase cur. Or what are we erasing again? We'd be erasing T2 or T2 reg get name. So that's what we need to do. I think that would fix the seg fault at least. What? So that's still seg faulting on the print. You handle debug mode. I'm not really sure what the question is. Also, don't worry about asking questions. I'm happy to answer them. I guess like the big trouble with debug stuff is like adding debug symbols. So like, I guess turning things back from like registers to actual variable names, I guess, is the hard part of it. I did that once with like one of my tutorial projects, but I haven't thought about it since, so I can't really give an informed answer here, I think. Okay. So I guess maybe I should reason about this as like things I do with T2 and things I do with cur at each step. So this is fine. So that fixes the node state. This should fix the functions, or the current, I guess like, current function state. So then, the hell do we need to change? So we need to... I don't think we need to change a lot here, actually. So everything that you... Oh, wait, no, I think I get this now. We don't want to erase T2 reg, I think. So every one of... So out of T1's loops, T2's uses... We should get rid of T2, I think. Is erase correct? Yeah. So that should be... So we should erase that, and then... Yeah, we should erase cur, and then... We should erase... Yeah, okay, so we erase cur and then we move all of... No, we erase T2. We move all of... We replace all T2 or all cur instances with T1. So that's what we do up here. So that should be fine. This section should be fine then. So now we need to update the leaves. So T1's leaves should drop T2 itself. And then the new leaves are the children or the leaves of cur. So we get the leaves here. We add them to T1. And then here, what are we looking for? We're looking for just T2, I think. Oh, Jesus. Yeah, we're looking for T2 in here. T2 is no longer a leaf that we care about, so we erase it. And then here we want, this is a unique putter. Oh, wait. This might be more useful here. That might, wait, that could be huge. Okay. So we do want erase here, right? I think this is a vector. I forget. What is context? This is a list. Yeah, okay, so we want erase here, I think. Or actually, we can just like... We're like linear searching through this anyway, so we can just do like... cur iter, right? Let's delete this sloppily. This should be deref not. Okay, that makes sense, actually. I don't think... This is tracking the wrong thing, I think. This should be cur. Okay, let's try this again. I don't know if we made forward progress at all, but we may have not made forward progress at all, guys. Okay, well, what part of this is seg faulting then? What part of the print, at least? At 160. Try merge. Let's go to 138. Oh, so the node itself in the uses is... The node itself is invalid. Had rain in the background on full volume? That could work. But you could also do that yourself, right? Like you could just pull up a 10-hour rain video and just add that. Nothing's stopping you, but I fear copyright might be stopping me, unfortunately. So yeah, you're free to do that as you please, but I will not be doing that. Oh, wait a second. Wait. Yeah, okay. So this is a null pointer. So the node itself in uses is a null pointer. Wait, so that means we're not deleting it properly from uses. Other YouTubers are doing it? Yeah, well, I don't know, like, cool, I guess. Like, I want to, like, I've been, like, trying to stay somewhat minimal with production. Maybe, like, maybe it works for, like, everyone's favorite, like, maybe, like, other YouTubers are doing it, but, like, I don't see why that means I should. Like, it's still my stream. I get to do what I want with it. Apologies if I come off as rude, by the way. Like, it is something I thought about at one point. It would, like, fit the aesthetic. Maybe I'll do it in, like, a proper edited down video, but I think, like, for a stream proper, I think it can get to be a lot really quickly. So I will keep that in the back pocket if I were to edit something down. Maybe if I make like a code with me for 5 hours video, I'll do that. Okay, so this erase is not working. Or something is wrong here. Wait, so what's quitting on me? So what was dropped was this. So we dropped cur. Wait, is this just cur? Oh wait, no, I can't do it like that. Oh, I closed out of it. Whoops. Okay, so we're getting rid of the cur. So then any ref to cur is unsafe, but we're getting rid of all of these. Right? So that shouldn't be a problem. This is a ref, so that should be erasing old leaf. And then get leaves is just a ref, right? So we can just like, wait. Oh wait, is it failing in the leaves? No, it shouldn't be. That's not what we're dereffing. Okay, we're gonna throw the debugger at the problem, I think. Test, regression, input, test. Debug and mechanic. Okay, so that's valid. So then what is node? So let's step into this. Alright. So node has a size? Oh wait, no. Node exists. So then what's wrong here? This is fine. What's good, Ogre? Good to see you. Welcome back to the stream. So then... so the op exists. So that's fine. Oh, is this the first pass that just occurred to me? Yeah, this is the first pass of this. Okay, this is where we care about the scopes. Okay, node is a null pointer. Okay. Find this on Army 7i tool chain bugs? Youch. That does not sound enjoyable. I'm doing roughly the same thing here actually. I'm fighting the bugs that I have written into this. There's no experience like writing git blame and then seeing your own name pop up. So that's where we're at right now at least. So this is a null pointer for some reason. I don't know why it's a null pointer. So in uses. Okay, so what is stir then? So uses of 1 is a null pointer right now. So that 3 was deleted. Oh, wait, what? Wait, so, okay, so that 3 uses 1. So that 3 doesn't exist anymore. Because 3 has been merged into 4. What language are you compiling? C++ is the most popular wrong answer. The compiler is written for C, at least. The compiler I'm working on goes from C to x86-64. But I'm writing it in C++. So I guess in a sense that's the correct answer, in a sense that's the wrong answer. It's up to you which one it is depending on what you were asking. Okay, so 3 has been merged in. So then leaves of 3, 1 should be one of the leaves. So then this should not be a null pointer when we do the replacement down here, or after we do this replacement down here. Yeah, we're replacing cur with T1, so this should be fine. What does this find? Unless this doesn't work. That would be very tragic if it didn't work. Is this an L value? Okay, we're throwing in the chat for a second. Is this overwrite over find? Are legs okay because it said that C++ people lose their legs? I've never heard that. I've never heard of that before, but my legs are very much fine, at least. Maybe I should do like a standing desk stream. Oh, wait, this is a copy? Oh. God damn it. Okay, I think we figured it out, guys. Guys, I think we figured out what was wrong. That's so stupid. That's so stupid of me. Yeah, okay, well at least it prints now, but now it's cycled somewhere else. Okay. It looks like it merged correctly though, which is a good sign. Yeah. Okay. There's another issue somewhere here. So what's breaking now? That's such a stupid issue. I can't believe I forgot. Oh my god. Okay. All good. Okay. So now it's at 43. 43 is breaking. That's the one that breaks? Okay. Whistle for some reason not casting a sign type to void star pressing macros. Yeah, that's not enjoyable. I guess like that's something you could like push a patch for, right? Or is that like what you're actually working on? That'd be quite funny if that's what you're working on. Okay, let's send that. Let's unset the breakpoint. Let's launch last. Let's see where it breaks now. Oh, that's not helpful to me. Let's go back here. It's well documented Musso doesn't want to patch. That's irritating. Yeah, I mean it is what it is, I guess. That sucks. This should be fine, right? This first pass is fine. Okay, that second pass is not fine. So let's try that again. We can run once, we can break here again. Step over, okay. Okay, so what is T2 iter then? I forgot for the longest time. I like did all this work to set up my like debugging setup, and I didn't remember I have like all these nice tools down here. Breakpoints, like threads make sense. I've always looked at like, I don't think I've looked at any of this historically actually. I should just be looking at this more, holy hell. I feel stupid for not using this for a while. Oh, it's the Bjorn quote, I see. In C you can shoot yourself in the foot, in C++ you can blow your whole leg off. Yeah. Honestly, I feel like in C you can like, in C++ you can shoot yourself in the foot. In C you can like, in C you can blow your whole leg off. In C++ you can also blow your whole leg off. Like, I think like, they both have like very, they both let you write very dangerous code in different ways. Like C++ maybe just because like it's miserable to write. But like C in the sense that like there's a lot of like security concerns that exist. So things like buffer overflows. Like I think there's literally like a new buffer overflow reported like every day. It's actually very crazy to think about. Let me find this. Yeah, let's look this up. There's a special page for this somewhere. This was mentioned in one of my classes, so I can definitely find this real quick. But it's really funny. Like, my prof like literally updates the slide every year, like the day of the lecture, and like there's a question which is like, when was the last buffer overflow vulnerability reported? And like, the most common answer is today, and the second most common answer is yesterday. So it's like, it's really crazy to think about. Let me pull up the slide actually. Let me find the website even that it lives on. Okay, system security. This is for my OS class. This is too far in the slides. It has to be above here. Oh no, maybe it's not. Maybe it's further down. Okay, found it. So this is the website. Accept cookies. This is the security CVE's like published website. So this is today in UTC. Let's search buffer. Or how do we filter this? Also, let's make this dark so I can like not kill my eyes. Can I just search buffer? How do I search this thing? By type. There we go. Overflow. Yeah. Let's look at it by overflow. 2025. Sort by publish date. Yeah, today. Stack-based buffer overflow. This is literally today. Like, if this is not proof that C can, or just like, I think this is C, right? I'm fairly sure. What is CGI? Containing code and yeah. I think this is C code. I would not be surprised if it was C code. Anyways, the next one is also today, and the one after that is today. So like, everything is a buffer overflow. Yeah. So bottom line, any language lets you shoot yourself in the foot. And the fact that there's so many buffer overflow related ones means that it's even easier to shoot yourself in the foot in C, at least, because it is probably easier to do that in C. Every day is a good day for buffer overflow? Hell yeah. Yeah, that's how it is. Bottom line, yeah. We can all shoot ourselves in the foot very easily. Today's a pretty Friday, but I'll lock in because you're locked in. Good to hear. Yeah, I mean, it's always a good day to lock in. What is T2 iter here? Oh, I can expand like that. That's really cool. Okay. So there's an invalid iterator inside of T2. So it's in T1 leaves. Can I like look through T1 leaves maybe? Oh, interesting. Wait, what the hell? Huh. What is happening here? So it's 3 and then 1 and then null pointer. Generic null pointer. Source null pointer is fine. This is not fine. What is happening here? Oh, the for loop's invalidated. Yeah, that would make a lot of sense. Yeah, okay. Or at least, like, the iterator is invalidated, at least. Okay, so this might have to become a list then, just to be safe. Yeah, let's make this a list instead. And hopefully that solves all of our problems, because that always solves all our problems. Yeah, okay. Let's make this a list. Let's make this a list. Yeah, we love lists here. Everyone loves lists. There should be a list. This should be a list. There we go. Aha, gotcha. Okay, that's everything there. Let's just try this again. Hopefully this builds. That'd be very cool. It looks like it builds. That's a good sign. And if it runs, then I think we are home free, actually. We are not at all home free, but... Okay. Yeah, okay. So merged once, and then it broke again. Let's just run it through Valgrind, I guess. We can try it again. More thoroughly. Merge trees 33. So it's the same place. Right? Wait. No, it's a different place. What? Wait. Huh? Huh, interesting. Okay, well, the other way we could go about this is we could move this cannot merge outside somewhere. We can move this outside of the for loop. Even. Or no, this is fine. But there has to be a better way to write this to avoid this issue, I feel like. I don't think vector is the issue here. Or, I guess I should just leave it as list because that's safe, but still. That doesn't make sense. That doesn't make sense at all. That iterator is kind of necessary, I fear. So which line is it breaking on again? 33? Yeah. So it's breaking here. What are we calling? Oh, the increment? With iterator itself is invalid. Oh, that makes a lot of sense, actually, I think. Right? Because we kind of just nuked T2 from orbit. No, wait, no, T2 exists. No, this should not be a... What? Wait. Okay, we might need to... Can we just, like, reset T2 iter, actually? Is that a thing we can do? That would be really funny. Like this. Or something insane like this. If that is how we, like, revalidate the iterator, that would be really funny. Okay, well that still breaks, but... It looks like it breaks at a different point. Yeah, 61 now. That's so funny. Iterator is becoming invalidated? Just try again completely, I guess. Wait. So we're cycling somewhere else now. That doesn't make sense because we're out of things to merge. We shouldn't be getting to this point, I think. So where is the segfaulting? I guess I just mentioned it, but I should probably debug, yeah. Or I could also, like, not use the debugger for no good reason. I'm gonna use the debugger. Yeah, I fold it like that. Okay, which line is breaking? So 61 by the dynamic cast. Wait, how is this the null pointer? Wait. Okay, let's define this in the silly way. I think end is not valid as well. So we do that. Let's make this T2 iter end. That's technically valid, albeit very ugly. And then we're just gonna do this gross thing again that we did at the bottom here. That might actually be it. If this is all it takes, that's gonna be so funny. It's not all it takes. Damn it. Okay. Okay, so what is... Oh, wait, that solved one thing. Now it's breaking in another different place, I think. 62. I lied, that's the same place. Damn it. Okay. Let's set a breakpoint there. Let's undo that shit. It was really funny that almost worked, I feel. But I mean... It was not gonna happen, let's be real. Okay. Is this still the breakpoint? Yes. So let's make again. So let's run that again. Actually, let's set the breakpoint here. That doesn't help me. Okay. Set the breakpoint there. You should launch last. Let's pull this up again. This is fine. This is fine, right? What is happening here? Okay, that's fine. Okay, so that one fails. Okay, let's launch last. And then, okay. So this seems to be the problem. Cur is an invalid address. Probably because it's end. I guess I should probably check for that. That would probably be safe. So let's do if cur equals, in parentheses because this isn't Rust. We want T1 leaves end. Then we want to break, I think. Yeah, okay. So that doesn't work. Or let's throw it like this. Creator. Bat end. Should be end, right? Unique what? What is this? List iterator. This is list iterator of node star. Oh, what the fuck? Wait, am I? What? Oh. Wait. Oh. Context end. That's what we want. What is the boundary of the range of this while loop? This is the scope, so let's go to the other end of this. This lives inside this for loop. Okay. So now we just pick a new leaf and then life is good. Okay. So that's the cannot find case, I think. I'm not really sure why it's getting to that point, but... Oh. Yeah, okay, that makes a lot of sense, actually. I guess we should probably handle that explicitly. Hopefully it works now. That'd be very cool if it did. It still doesn't work. Okay, great. Alright, let's throw Valgrind at it again. Oh, this is way smaller, though. 65. It's in the same place? Oh, we should put this down here. So if it's out of range at that point, because this is a prefix increment, so we should do that. Whoops. Yeah, okay. Okay, it works. It looks like it merges now. Holy shit. Okay, let's get rid of all the print output now. Because I don't care about that yet. Or I should at least comment these out. I feel like I will care about those in the future. When some piece of the merge logic breaks. You should get rid of that though. Or at least, I don't know. Ah, what the hell? Let's just delete all of it. What did I change? Okay, so that. So let's get rid of that. Let's get rid of that. Let's get rid of that. Let's get rid of this whole loop. This whole loop of slush. Okay, that's all the print output. Let's get rid of IOStream. Let's rebuild it. I think this merges now. This should merge trees correctly. Yeah, okay. That does what we want it to. So let's give it a more complex test. Oh, that's ugly. That does what we want it to, but that is ugly as hell. Mem to reg. Uh-oh. That's not supposed to happen. Okay, maybe I've celebrated too soon. Let's give it test again. Let's give it 0. That works. It looks like it works. It's just loads, so this should be fine. Yeah, that looks reasonable enough. Yeah, okay. I wonder why it didn't try to merge into the store. This should be an AND actually, right? Why is this an OR? Right or no? That one should be an OR. That one is an AND. So I'm not sure why that's not merging then. That should be merging. So if T2 has a memory, these don't have it though, right? These are just loads. Maybe these don't have dependencies. Right? I hope nothing else uses 22. I don't know. I'll evaluate that later. This seems actually very good though, to be honest. I'm very happy with how this has gone. Let's give it something like really complex. Let's give it like call chain. Okay, well I guess that's just a mess. That's not really complex. Okay, what else would be interesting? Oh, while could be interesting. Yeah, I ain't reading all that. Yeah, I ain't reading all that. Let's give it... I think the interesting one is just mem to reg. Yeah, that one works. Which one was breaking earlier? With the assert. Something was breaking. There it is. This one is... Oh, memcharge after it. Right? So after opt, it was breaking. What about while? Okay, while is fine. If is fine. Let's give it... So it is just the mem to reg one. Interesting. Okay, let's valgrind this. Okay. Like merge trees 140, merge trees 39. Oh. Okay, I need this as well here. Yeah, okay. I guess maybe an empty one would kind of cause that problem. Is that fine? Okay. Okay, so that solves that issue. That's just kind of an oversight on my part. Okay. Wow. Okay. That's really cool to look at for some reason. Okay, maybe we should like add a test for this, or let's rewrote tree merging plus it actually works now, lol. I should probably get rid of the prints here. Yeah, let's clean that up. And then if I need that again, I can just like pull it from the git history. Or I guess we could keep the after. Yeah, we can do that, I guess. Let's get rid of the after line. That after line is annoying. Let's rebuild. Okay. Okay. So that prints things now. Yippee, that's really good. Yeah, let's do that. Real quick, just out of curiosity, I think we should add a quick little regression test and just see if it literally just runs on everything. So let's edit the runner real quick. Let's add a quick test. So let's do this. We also want without passes version, so let's just like throw this in here. This should be LAR with passes. We can do this very boilerplatey. So let's go to driver, let's go down here, let's steal our code for this. Save that. And then MIR, we have backend. This should be auto. We should include LIR real quick, or I guess like backend, MIR to LIR. Oh boy. Okay, there we go. We don't need these anymore. Oh, that's a bug on my wall. Oh, that's a spider. Hello, spider. That looks rather creepy. Let me kill it real quick. Alright, we're gonna say hi to the spider. We're gonna say bye to the spider. Alright, give me a second. Let me throw this away. Alright. You said bye to the spider. I wonder if you can overload the arrow operator and have all phases done that way. Yeah, that could be something that I do. I think the arrow operator, or just like overloading operators in general, is a little bit scary because like then like you forget you overloaded it and then like you expect some behavior and then like it doesn't do what you want it to. For what it's worth, I think the double arrow operator, I think very frequently is how like toString is implemented, but I've been too lazy to do that at least. I guess that's like one of the few instances where it's probably justifiable. No, don't kill it for what? Well, you see, I formed a bit of an alliance with the silverfish in my room, so it would be a little bit of a betrayal for me to side with the spiders and not with the silverfish. Do you get what I mean? Okay, so all these tests check for is just that it doesn't segfault. Let's just build real quick. There's no asserts here, but linker issue. What? To MR to LIR. What? What? So this definitely exists. Oh, wait. CMake lists. We need backend. Whoops. There we go. This should be good then. Okay, perfect. So the runner builds. Alright, please work. Oh no, something. No, there's an infinite loop somewhere. Oh, that's not ideal. Okay. Which test is this on? On the while test, really? Okay, let's give it a while. Dash 0? No, that's not. Wait, what? Why is it hanging? That doesn't make sense to me. Huh? That shouldn't be hanging, just period. That? What? What the hell? Okay, well, let's go back. Let's like re-comment the print output, because that is making a mess. Okay, so it does run. Yeah. What the fuck? Okay. Wait, but there's no okays here. Wait, what? Wait. It's not running the while test with passes. Okay, let's run this. Let's val grind that. These colors, I like filter it through stuff. Ah, I see. Okay. So that's an interesting issue we're running through. All right, let's, instead of running that, let's just run build-in regression tests. There, this way. Okay. So that's hanging somewhere in simplify CFG with passes. That. Aha, okay, that's interesting. Alright, that will be something I need to look into next time. Let's actually just restore changes in test. Let's just undo the runner changes. And then let's add print output again. Okay. Let's just push for now. We will add the correct tests eventually, because I don't want to get spammed by emails every time I push. So which ones are failing again? Simplify CFG is hanging. Let's go back up to where there were colors, or not colors. So which ones were failing? Or which ones were not running? Test to skip. Oh, these might be skips actually for the most part. Wait, but this runs. Oh wait, no, that passes. Wait. Yeah, okay. So that's where it like hangs. So I'm gonna look into that maybe. So this is fine. More debugging. Tree merging. And then the one we care about is simplify CFG with opt. Okay. This will be next time stream. Today, this time is 94, right? Yeah, 94. So next time will be 95. Yeah. Let's get Japanese characters. I still cannot read your name. Especially now that it is a tag, it is just kind of doomed from my end. Good to see you. Unfortunately, I think I'm about to wrap up stream, because it's been like, this has been the first time in a while I've streamed for longer than 2 hours, so it's good to finally be back in the groove of things. Yeah, it is what it is. Anyways, is this pushed? It's pushed. Okay. Yeah. So I think that's it for today. Thank you all so much for showing up today. It's been a pretty good stream. It feels good to finally do long streams again, since I have time again, and energy as well, I guess. Yeah, if you haven't already, make sure you like the stream and sub to my channel. It really helps out a lot with the algorithm, and it gets my content out to more of you. The growth has been incredible over the past few months. I don't think I could have predicted this, and it really does just mean a lot to me. While you're down there in the description, make sure you join the Discord if you haven't. It's the best place to get pinged when I go live and chat with me in the broader community. Everyone's pretty active actually. It's a pretty nice place. And also in the description is my GitHub and my LinkedIn. You should add me on those platforms if you want to stay up to date with what I'm doing. Yeah, that's about it. Have a wonderful rest of your Friday or Saturday, wherever you are. And yeah, take care and take it easy. I've completely messed up the order on that, but you get what it